Assalamu alaikum warahmatullahi wabarakatuh. Welcome again in the third part of our mini revision. Okay. Now, inshallah, Rabbil Alameen, in this part, we will continue talking about the practice on what we have studied, the kinematics equation. So we will study set-like examples. We will study set-like examples or examples in form of set 2 physics questions. A ball tossed upward. When I say the word upward in any problem, it means there is a given here. There is a hidden given here. What is it? It means acceleration equal negative, g equal negative 10 meter per square second. 10 if you make approximation or rounding, okay, which is 9.81 meter per square second. It's up to you, but this is easier to be used. Okay, from a bridge that misses, let's continue reading, from a bridge that just misses the bridge on the way down and lands on water below. So here, this is the bridge. This is the bridge. Okay. We throw the object up. Then it falls down till it reaches water. Well, as shown in the diagram above, it's not above, by the way, it's below here, okay, because I forgot to put the figure. Or I preferred, let's say preferred, it's better than forgot, okay? The elapsed time for this motion is 3 seconds. So this is the first given, 3 seconds is the second given, okay, which is t. Where is the third given? Sorry, we skipped this given. The bridge is 24 meters above the surface. So this length is 24 meters. So now let's solve the problem. It will be a big stupidity if we say that y is 24. Why, mister? Because y is 24. This is neglecting the direction. It doesn't pay attention to that the motion is moving downward. So let's see this. Here, this is the initial position. This is the initial position. And this is the final position. The distance between them is 24, but it's moving downward. As you see, it's moving downward, so it's negative. So y is negative. Y is negative. Why is y negative? Because it's moving downward, and we said we have standard directions. Downward or north, downward or south is negative. West or left, negative. And the other directions are positive. Well, the free fall acceleration g, or negative g, it must be negative, by the way, okay, equal negative 10 meter per second squared. And the time is 3 seconds. The question now, what these are the givens and what's the required? It's v initial, the velocity at which the object is launched. Okay, someone may ask me a very strange question. Okay, someone may say, Mr. But please, the object doesn't move here. The object doesn't move from the initial position to the final position directly. It moves up, then it falls. Yes, I know that. But what is what is y? Y stands for what? Y stands for what? Y stands for displacement. And what's displacement? Displacement is the distance or the straight length from the initial position to final position, regardless the real path of the object. The object here moves in a curved path, up, then down, but the displacement will be directly down. You get the idea? I hope so. Well, so now we will search about we will search for an equation that contains y, g, t, and vi. In fact, it's this equation, which is the third one. X equal v I t plus half at squared, because it's positive motion, because it's a free fall. Okay, x will be replaced by y, a will be replaced by negative g. Okay, so it will be negative 24 equal 3 vi, 3 the time, 3 vi plus half, g is negative 10, and t squared, 3 squared is 9. Solve this problem to find that vi equal 7 meter per second. So the correct answer is C. I have got the answer. Well, now we will study the second question. The second question says the driver of a car moving at, look, 20 or negative 20, no, negative 20 meter per second. So here I have what? Yes, I have a given here. This is the first given, sorry. This is the first given, which is Vi equal negative 20 meter per second. Well, he noticed the light has changed to red, so he has to stop. When the driver applies the brakes, the car experiences deceleration of 10 meters per second. So this is the second per second squared. This is the second given. A is 10 meters per squared second. Someone may say, yes, Mr. Yes, I know it, because he said deceleration, we will use negative acceleration. I'll say what? I'll say no, it's not accurate, because the acceleration, the negative acceleration in SAT doesn't mean deceleration. Deceleration means the acceleration which is opposite in its sign relative to the initial velocity. In other words, if the acceleration is positive, it doesn't mean it's speeding up or slowing down. It doesn't mean anything. We will not say it's speeding up or slowing down before knowing what is the sign of the initial velocity. If the acceleration is opposite to the sign of initial velocity, it will be it's opposite, so it will be slowing down, even if it's positive, such this case, okay, like this case, okay. But if they are in the same direction, or if the initial velocity is 0 and anything or any thing except for 0, it will be speeding up. So slowing down means A is opposite in direction to VI. It doesn't mean A is negative. Okay, I have you picked this idea. So the acceleration here will be positive 10 meters per second squared. How far is asking for what? Is asking for x. So the x is needed. How far will the car travel before it stops? Do you see this little poor word? It has a hidden given. What is it? It's V final. Be careful, be careful. The hidden givens are so dangerous. So we have V final, A, V initial, and we want to know what's X. Let's solve the problem or see the answer. Okay, so the givens are Vi equal, as you see, Vi equal 20 meter per second, A equal negative 10 meter per second squared, Vf equals 0, X is unknown. The Switzel equation is that one, V final squared, which is the fourth one. Okay, V final is 0, Vi is 400. The acceleration here, excuse me, I'm so sorry. Here, the acceleration, it's not negative, it's positive. It's positive 20x. Okay, so x will be negative 20 seconds. Okay, negative 20 seconds. Why is it negative? Because it's going, for example, let's go west and so on. I hope you got the idea. Now, inshallah, let's see the questions 3 to 5 on this graph. Question 3 to 5 relate to the velocity versus time graph. Let's remember, velocity versus time graph. Velocity on the y-axis, time on the x-axis. Before answering this question, we have to ask ourselves, what is the slope of this graph? The slope is delta y-axis divided by delta x-axis. Delta y-axis means delta velocity divided by delta x-axis means delta time. So this is the acceleration. So the first point here is to say this is the acceleration. You have to remind yourself before solving anything, the slope of velocity versus time is acceleration. So this segment is horizontal. This segment is horizontal. So it means the velocity, the slope is 0. So the acceleration is 0, not the speed is 0. Okay, so don't look at this and say, oh, mister, it's horizontal, so it's at rest. No, it's a stupidity if you do that. Okay, I know that you will not do that, inshallah. Okay, but that means what? That means the slope is 0. What's the slope here? The slope is acceleration, so the acceleration is 0 and the velocity is constant. Here, the slope is negative. Here, the slope is negative because it's going downward like this. It's going descendingly. Okay, so this the slope here is negative and the acceleration is negative. In this part, the acceleration is 0 again, but in different velocity. Now let's read the question. Determine, this is number 3, huh? Determine the magnitude of acceleration from 2 to 3. From 2 to 3. He's asking about the magnitude of the acceleration. And the acceleration is the slope. The acceleration is the slope. At the line here, between these two time intervals, or these two moments, is horizontal. So the acceleration is 0. So the question 3, A is 0, because the slope is 0, and the slope is the acceleration. You got it? Well, we talked about a very important point. We said in this, especially in this graph of velocity versus time, the displacement equals area under the curve. Well, okay, he is asking in number 4, he is asking determine the displacement or change in position from 3 to 5 seconds. From 3 to 5. It means from here, from 3 to 5. What he's asking about the displacement. Displacement is what? Displacement is area under the curve. So it means that area. How can I find this area? I can find this area by dividing this region into two areas. This is one, and this is another one, and this is another one. Well, to find, so the area here, the area here is a rectangle plus a triangle. The rectangle is the width, the length of the rectangle is from 3 to 5. So the length is 2. So the rectangle, its length times width. The width here is what? Is 5. The width here is 5. Okay, so 2 times 5 plus. What about the triangle? This triangle. What about the triangle? Half base. The base is what? The base is 2. So half base, which is 2, times height, which is from 5 to 10. So it's 5. Okay, so it will be half times 2 times 5. So the total will be 15 meters. Okay, so the area is a rectangle plus triangle. So the area is 15 meters. Well, let's see the third one. Determine the magnitude of acceleration from 3 to 5 seconds. Let's see, from 3 to 5 seconds. Okay, so here from 3 to 5 seconds, from 3 to 5. What is the acceleration? The acceleration is the slope. The slope is rise over run. Rise over run. This is the run. This is the rise. Okay, here it's from 5 to 10. So it's 5 units, 5 meters per second. Okay, the run is from 3 to 5. So it's 2. So it will be slope equal rise over run equal, the rise is 5 meters per second. The run is 2 seconds. So it's 2.5 meter per second squared. Sorry, meter per second squared. But Mr. It's here, the slope is negative, by the way. The slope is negative. Why? Because here the change in velocity is negative. So this is negative. I'm sorry, this is negative. So the slope is negative. Okay. Why did we write it positive? He is asking about the magnitude. He said, what is the magnitude? And the magnitude means positive only. I hope you found the idea. And finally, inshallah, I mean to finish this mini revision. Number 6, a mass undergoes a constant acceleration from rest. This is a hidden given. From rest, so the initial equals 0 at 4 meters per second squared. It undergoes constant acceleration, so A equal 4 meters per second squared. What is the displacement? So he's asking about x of the mass at the end of 10 seconds. So this is time. So the givens here are 3. Vi equals 0. A equal 4 meter per square second, T equal 10. and the required is x. The only equation that has the givens and the required together, I told you, search for the equation that has all the givens with the required. What is this equation? It's the third one, which is x equal VIT plus half AT squared. VIT is 0, so all the first term will be cancelled. This will be 0. Okay, so it will be half 4, 110 squared equal 100. So it will be 200 meters. So the answer is C. And Alhamdulillah, we finished. Thank you. I pray to Allah to help you and guide you. Thank you. Assalamu alaikum.